This week on Let's Make It, we have 5 sensors. 4 of them work, 1 of them is flaky. But we're going to go through 5 different sensors. I've kept promising sensors, and this is the sensor week. And we'll talk about all these sensors, pros and cons, show you the code, all that stuff coming up right after this. Today on Let's Make It, in episode 6, I'm going to finally get to what I promised you before, and that's sensors. And boy, we're going to have some sensor fun today. We have 5 sensors that we're going to go through, all for the Arduino. I actually have 4 different Arduinos sitting here, and we're going to go through each sensor one at a time and look at some code, talk about some of the difficulties that I actually had with a couple of the sensors, getting them to work, and also some difficulty that I had with that LCD shield. I'll talk about that as well, and so you won't fall into the same issue. So the very first thing I want to talk about is a temperature sensor. Now I have other temperature sensors that are on the way. The one that I'm going to demonstrate today works a little differently than the other ones because it's really a digital output from the temperature sensor, where the other ones I'm going to look at, the Dallas ones, are not digital outputs, they're actually analog outputs. So this is going to work a little bit different. But this is actually a very great sensor because it gives you more information than the Dallas sensor does. This gives you humidity as well. It gives it to you in Celsius or Fahrenheit, and it does some other things in there as well. So it's a great sensor. It's not much more than the Dallas. It's more protected, so you're going to see that in a second. It makes it a little bit harder to test with because you just can't grab hold of it and test it and get the temperature to go up. You can do that, but it just takes a little while for it to start realizing you're touching it. So I'm going to hop over to the Arduino. Oops, where'd it go? So what we have here is the Arduino, which is on the bottom down here, the shield that I showed you last week, and then over here we have a breadboard, and you see this little blue thing. It's a temperature sensor. It's kind of behind the wires of the camera, but you can probably see it better now. So inside of there is all the electronics for this temperature sensor. And what you're seeing on the screen right now is it's bouncing around saying what the temperature is in 25 degrees Celsius right now, and it's 77 degrees. It's actually kind of warm in the studio right now. So it's going to keep bouncing around, giving you humidity, and just going to go around in a circle. And you see down at the bottom this word OK. That's one of the nice things about this sensor is there's ways you can check to make sure it's actually responding. And a good way for me to test that is if I take and I pull off the lead, and we let it go through its cycle, and you'll see in the program why it's going to take it 1 cycle to go through here. It'll come back up and it'll say timeout error. So you now know that what you're getting back is not valid data, which is very nice. And it's built into the way that the chip works. So we can push it off to the side, and you'll see it comes back up and it's okay, and it's reading data. And it's actually not too difficult to learn to use. The biggest problem I had with this was the shield. I was initially thinking that these pins were, since they were above the Arduino pins, came straight through. However, that's not the case. In fact, the pin that I'm using is actually pin 12, and pin 12 is normally up here if you look at the Arduino, if you look straight through the Arduino. So that took me for a loop for a little while until I figured out that it's not pin. I actually had to go through with a logic analyzer and figure out which pin was pin 12, or where the pins were. So I will document some of the information I found about this because there's very little documentation about the shield out there and how it's wired. There's a schematic and gives you jumper numbers, but nowhere on this board does it tell you what jumper is what. So the schematic doesn't really do you much good in that case. And the board on the back is black, which makes it very hard to follow runs as well. It looks pretty, but it makes it very hard to follow runs. So, okay, so back to the temperature sensor. All this temperature sensor has is 3 wires. Actually, there's 4 pins on it, but the 4th pin is in non-connected pin. So I'm not quite sure what its purpose is there, or if maybe it's something that they've repurposed another board or another chipset for. So you have, obviously, 5 volts to run it, and then you have your ground. And then what I have here is the green wire is actually the digital sensor wire. And this goes into a digital pin, like I'm using pin 12, which is a digital-only pin on the Arduino, instead of going in through analog 0 through 5, which is how like the Dallas ones work, which I still have that one coming, and I'll do other episodes with more sensors. In fact, I have a bunch more sensors coming. They're just not here yet. So when they get here, I'll do other episodes. But I figured for tonight, 5 of these was plenty. So let's go take a look at the code that I have for the temperature sensor. And it actually is, you see I have the liquid crystal.h because that's how I'm displaying the data. Now my other sensors tonight, I decided just to use the serial print just to demonstrate how they work. It was too hard to change everything around live here. So that's why I have 4 different Arduinos, all of them with different projects on them. And the simplest thing to do was just to use the serial print because it was connected all the time. The other thing is if I use that shield, a lot of the pins are used. So you use very few pins, and you'll see some of the other projects require quite a few pins to actually work. So, all right, so back to the program. You see I'm including liquid crystal.h. Like I said, that's for the shield. And then I include the library DHT11.h. And this is actually something that I'll put a link to in the show notes. It's a library for this particular temperature sensor, which makes it very easy to use actually. Then you see here liquid crystal. I actually take and define the 8, 9, and 4, 5, 6, 7 pins, which we talked about last week for this particular shield. And then I define the temperature sensor library and what pin it's on. Now this is where I was having problems because when I put it on pin 12, I could never find where pin 12 was. I didn't know that was the problem at first. I thought something was wrong with the temperature sensor, but it ended up being that I was not plugging into pin 12 like I thought I was. So basically you define a library, say it's on pin 12. Now by doing this, you'll see in setup I say attach to pin 12. I can do one or the other. I don't have to do both. I'm doing both just because I wanted to make sure it was working. I never took it back out. You could actually take out the 12 here and it would be fine. Okay, so after we attach, we want to turn our LCD on. So I'm using a 16 character 2-line LCD. And when it first starts up, it says let's make it at the top. That's actually a leftover thing from last week. And I wait 1 second, and that's just basically to let the temperature sensor come up. It doesn't have to be a whole second, but since I had let's make it on the screen, I just made it one second. It does require, I think it's 10 microseconds to get itself up. So the next thing we do in our loop is we then read the temperature sensor. And we define the variable as CHK, and we set the cursor to the second line, the very first position. And what I'm going to do now is look and see what I got back. So I did the CHK back, and it's going to tell me if it's equal to 0, everything's cool, everything's working fine, we can talk to it. But if the library cannot talk or has other errors, for example, a -1 means I have a checksum error. So I've never seen this yet, but I assume that you can have noisy data, and that would be your checksum error. The one we just saw was the -2, which was the timeout error, which basically means I'm not getting any data. And then the default, I say unknown error because it's an error that I'm not aware of or not documented. So then I come down and I set the cursor to the first line in the first position, and then I'm going to print the word humidity, and then I'm going to call the library, and I'm going to do a humidity. So I'm basically sending out the humidity, and then I'm adding a %. And then I wait 4 seconds. I go back to the beginning of the line, and I print out temperature, and then I grab DHT11's temperature. Now here's the thing, the default temperature that it reads is in Celsius. So you'll see that I put C here for Celsius, and you'll see right here, after I delay another 4 seconds and set the cursor back, I then call the Fahrenheit procedure. Now one thing you're going to notice is temperature and humidity are variables. Fahrenheit is actually a function, so it's probably taking the Celsius value and converting it to Fahrenheit and returning that information to you. So you see then the F for Fahrenheit, and then I wait another 4 seconds. Now the reason it took so long for it to say that there was nothing attached or it was a timeout error was because I pulled that pin in the middle of these 4 second waits. So if I pulled the pin while it was displaying temperature, it would be another 8 seconds until it got back to the top where it did the check. So that's why it took so long to show the timeout. If I wasn't waiting that long, it wouldn't take that long. So that's basically the simplicity of this temperature sensor. There are other functions, and if you download the library, you can see the other functions. There's actually some sample code in with the library when you download it as well. And you look at the functions, there's other functions that do, I can't remember what they even were now. There's more functions for conversions like the Fahrenheit and Celsius conversion, and a bunch more sensors type data you can get out of it. I believe one of them may even be like wind chill or something like that. I can't remember exactly what it was. But there were other functions that were very similar to that. So that's our first project. Now what I'm going to do is I'm going to switch to our second project. And by the way, all this stuff is going to be in show notes on the website. So if you have any questions, I'll point you to the library. I don't have any schematics created because I was running so late with the show, but I will get schematics created. And this is, like I said, these are all very simple wiring diagrams, but I will get them created and put them up on the show notes as well so you can download those. Okay, so that was our first project, temperature sensor. And before we go on to the second project, which is actually an accelerometer, which is like your cell phone, and we'll get into showing you that. I wanted to talk, we had a couple people ask about the best place to buy this, and I don't really know there's the best place to buy it, but where I've been buying it from is Amazon. So what we've done to help you out is at the bottom of these show pages, we have links to the products that we talk about in the shows. So if you're interested in learning how to use a temperature sensor, or maybe an Arduino, or you want Arduino Shield, something we've talked about, you can get all that stuff from the bottom of our page. But I want to be upfront selling you those links to Amazon. We do get a 4% commission on those. It's not a lot of money as far as commission goes, and anything we make does come back into the TechZen TV network to help pay for our bandwidth bills, things like that. But I do want you to know upfront that there is a commission there coming to us. Like I said, it's 4%, but it's an easy way, a quick way to find the products that we talk about on the show. So I want to hop over and start with the accelerometer. And you know, accelerometer is a device that basically can tell you what way something is facing in different directions. Your phone, if you have a smartphone, has it in. When you turn your phone sideways, you notice it changes different directions. Some games use the accelerometer. And there was actually an accelerometer that we purchased and got working with the Arduino. So we're going to show it to you. I'm going to hop over to the Arduino. I'm going to swap out this one, and I'm going to plug in the accelerometer. So let me go ahead and plug this in. Now the project's already loaded on the Arduino, so it'll be really quick. It'll start working right away. But the actual accelerometer is this thing right here. It's a little board. And this is actually, the accelerometer itself is actually this little chip right here in the center. And you can get these separately. This board's been designed to easily be worked, for projects like this. So basically on this board, what you have is on this side, you have your 5 volts and your ground. And then there's a pin here that allows you to specify what accuracy you want. So I've experimented with this and I see a difference, but I don't know exactly what the difference is. I know we'll show this in the data as we get it. And then on the other side, we have X, Y, and Z. So X in this case is blue. Green is Y. I'm sorry, purple is Y, and green is Z. And then the last pin is like the sleep pin. So whenever this pin is low, the accelerometer will not work. So that allows you to, if you have a project that uses an accelerometer, you can keep turning it off and on so it's not constantly giving you data back, which helps save the battery. In my project, I've just turned it on. So I haven't gone through the whole process of writing a sleep routine for it. So let me go ahead and get this connected to our serial port. And through the magic of editing, the 30 seconds or so that it took me to get this switched over, I'm switched over to my laptop. Now what you're seeing right here on the screen is the X, the Y, and the Z. And if we scroll down and we look at the code, we'll walk through the code real quick. So just ignore this bouncing around stuff over here. Basically what I've defined is the sleep pin. So like I said, the sleep pin, if this pin is low, the accelerometer is not functioning. So we got to make sure we put that pin high. We have the high precision pin, which by default it says it doesn't need to be connected. However, I have connected it and I've tried both the low and the high. I do see a difference whenever it's low or high, but to me the precision isn't much more than what it was before. So, but we'll talk about that here shortly. Then I have the X pin, which I've stuck on analog 0, and these have to go into analog, and that's because what it's returning you is a voltage level difference based on its direction that it's facing. So what you're reading is the analog value. Then we have a Y pin, and then we have a Z pin. Now I've used a 0, a 1, and a 2 for those pins. I set my baud rate for my serial monitor to 115/200, and if you come over to the serial monitor right here, you see my baud rate is 115/200. I take our sleep pin and make it an output, and then I turn that pin high, which basically turns on the accelerometer. In the event that you're trying to do some kind of battery saving technique, you adjust this and turn it on every second or every couple of seconds, which would save you some battery time. Then I come down to the X pin and I make it an input because these are all voltage inputs. And then I turn on the pull-up resistor so that it's high when there's nothing on it. Then I do the same to the Y pin and the same to the Z pin. So that sets up our 3 pins to be inputs with a pull-up resistor turned on. And then we get down to where the work actually happens. And you see I'm delaying 2 seconds in the beginning just for mainly readability of the loop. I could have put this at the bottom, could have put it at the top. It doesn't really matter. And then I'm serial printing the analog read value of X pin, Y pin, and Z pin. So what you're seeing on the screen over here around in a circle is the reading for each of those. Now right now I'm not touching the accelerometer. So I'm going to go ahead and pick it up. And you'll see the values just changed. But they didn't change that much. I just turned it 90 degrees. So you would have thought something would have changed. Now I'll turn it another 90 degrees. And it changed a little bit more. And now I'm going to turn it another 90 degrees. And some things changed a little bit more. But for a 270 degree turn, the numbers didn't really change that much. So I'm going to bring it back to where it was, and I'm going to twist it a different direction. There is 90 degrees. There is 180 degrees. There's 270 degrees. So and I haven't read up on this to know what the actual value range is, but from my perspective, the value range is not that great. I would have thought a minimum would have been 360 based on the degrees that you're turning it, if not more than that to make it more accurate. But in this case, it doesn't seem like it makes a difference. So that is with the, let's see, the high precision pin set to low. So what I want to do is I want to set the high precision to high, and we'll see what the difference is. And let me fix another little bug that I had there. And let me go up here and set my board to the Uno. And I'm going to push this back out. Okay, it's up there. Let me turn back on the serial monitor. Okay, so there's our reading, and I'm going to pick it up. I just turned it 180 degrees. You see the numbers changed, but the precision, I mean, the numbers didn't change as much as before. That's why I'm thinking that the way I had it before was actually the right way for a larger precision. So let me turn it this way. There's an 80 degree, 100 degrees the other direction. And let me just say that the chip on this thing gets a little warm. Gotta be careful when you hold it in your finger. So let me go back and set this low again. So you see the range isn't much above 600. It's in the 600 range mainly. So let's turn this back to low, and I'm going to push this out again. All right, it's uploaded. And back to the serial monitor. So you already see immediately that the 730 is above the 600 range that we had before. So let me turn it 9 degrees. So I do think when the pin is high, the precision is more. It still seems to me, I'm still turning it around. It still seems to me though that this is not something that is very accurate. And you see we're going into the 700s now, where before we weren't going that when the pin was low. So 500 to 700, so that's 200. I just don't think it's a 360 point precision. So I don't know what the precision really is. I'll have to figure that out at some other point. But again, this is what I was basically doing, was this, you know, twisting it from this way. So there's the 180 degrees, and then I also did it this way, and then up to 180. And the numbers to me are not as accurate. However, it definitely does give you what it's doing. What they determine X, Y, and Z, you have to play with it to figure that out. Like I said, the documentation on it's actually pretty poor. I have found some things online of people who have figured it out, but there's no special library required for this particular sensor. I mean, it's something you can. It's just you're just reading the analog in right off of the board, so you get the voltage that's coming in, and that's your value, and this chip outputs it in that way. All right, so that is the accelerometer, and the other thing that it has that I did not play with is there is what's called a free fall sensor, which to me means if it detects that it's falling, I guess like the IBM laptops that used to fall and they'd lock the drive down, that type of sensor. So if it detected that it was falling, it would the pin comes high. I did not try that. I didn't find much documentation other than what it was supposed to do, and because of the way I'm doing this, I don't really have an easy way. I mean, I could drop it like that, I guess, and it would go off, but I didn't really play with it that much. So the next one I want to do, before I get to the next one, let me do this. I do want to let you know, if you're watching live, it's great, but if you're watching this recorded, you can watch this live. We've recently moved the show to Tuesday nights, where we normally record at 7 p.m. Tonight we got a little late start, but even if we're starting late, we generally have the live stream going, and you can kind of talk with us beforehand. And while you're watching this live, it's awesome if you can get in the chat room and chat with us. There's chat rooms right up here. I see it right up here, and I watch it, you know, pretty closely. And it's great to get feedback from people, especially as we are recording. And if you have questions about what we're doing, we can answer them like right here on the show. So it's great for us. Okay, so that was the accelerometer we just talked about. Let's get back and do the next sensor. The next one is interesting to me. I have not quite figured it out, completely figured it out. All right, so let me unplug this one. The next one is a color sensor. So it's supposed to be very similar, like if you take a piece of paint or a wall into like Home Depot or Lowe's, and they can color adjust for it. So this is another Arduino Uno. So let me go ahead and get the serial port going while I'm doing this. I have the serial port running, and before I go show you what it's outputting, I want to talk a little about the sensor. Now you notice there's 4 bright white LEDs on here, and this actually can be turned off. There is right now a jumper on here that's turning this on, and I can easily take this jumper like this and turn it off. But I think it's probably nice to have that because you can tell colors better with that turned on. So in the middle of this chip, and actually I'll turn it off so you can see it until I'm done. I should have left it unplugged. In the middle of this board, right here is this sensor. So the way the sensor works is there's actually 4 sensors in there. The one sensor is clear, so it detects clear light. The other sensor is for red, so it has like a red filter. The other one is a green filter, and the other one is a blue filter. So you basically have 4 separate sensors, and each one of them will tell you what kind of light it's getting behind that filter. So on the board, you have your power on this side, so you have your ground and your 5 volts. And then on this side, you have your colors, and then you have 2, I'm calling them command pins for lack of a better word, but the pins determine what color you want. So it can read 1 color at a time. So you tell it what color you want, and it will start outputting the color. So you basically can only get 1 color at a time, and you'll notice in the program that when we do this, we actually have a wait period, and we go through each one, and it comes back and gives you the output in pulses. So everything we have here is digital, but it gives the output in pulses, like pulse width modulation, as far as the strength of that particular color. So when we go through the code, you're going to see this. So let me go ahead and plug this back in, so we get the light, and let me get something here that has color to it we can play with. So I'm actually going to use this to go across this coaster with different colors and stuff on it. But let me switch over to the computer. And you see I already have the color sensor code here on the screen. And right here in the serial, you're seeing that I'm sending out, it's at 0, 0, 0. It's probably not getting anything right now. But I'm going to stick it on the orange. And one of the things I've noticed about the Arduino itself is it gets behind in sending out serial data when it's as busy as the pulse width modulation keeps it. So give it a second here to catch up. Okay, so as you see, I'm having issues with this sensor, and this is not unusual for the sensor. One of the things I've noticed is it seems like the Arduino itself is very busy trying to keep up with this. So I don't know if something that I was doing wrong with this. I'm just trying to write out a serial, which will go through what it does. And this is actually from an example that I found somewhere too. So I haven't really changed much on it. And you see right now it's not outputting any information back to me. Let me just reset the Arduino. Oh, there it goes. Oh, so not outputting any data. All right, so let's go through the program. And what we have here is we are setting up the different pins that we're going to use for the data collection, and then also the output control pins. And we have counters, and the way this works is it's actually doing a counter, the number of pulses. So this count R, count G, and count B is how many pulses it got in a short period of time. So this is how we determine what our numbers are. So the numbers for R are between 0 and 255. The number for G is between 0 and 255, and the number for blue is between 0 and 255. So that's where we define all of our initial values up here. And then in our setup, we're turning on the serial port at 115/200, and we're setting pin S0, S1, S2, and S3 to output. And then we create a subroutine called TSC, and all what this is doing is it's setting up the pins. So what S1 and S0 high do, and then the two lows say I want to read the red color. So the two highs are telling it to read. And then we attach an interrupt routine, which is this ISR underscore into, and then we set our timer. So what the interrupt is doing is while this timer is running, which you'll see it's 10 millisecond timer, which we'll go through this down here in a little bit, but while this timer is running, we want to count for every interrupt, and we want to add to the counter. So the timer happens. So basically when we set the timer, this is the clock frequency, and then we want 10 milliseconds, and then we want to turn on the interrupt. And then the interrupt comes down here, and you see it go through, and it says what the flag is. So the flag is part of this whole routine. So every time this function goes off, this interrupt timer goes off, it comes down here and says, what am I looking for right now? So flag 1 is red, which is what the low was. So we set it to low, we set it to pulse, and we wait 10 milliseconds, and in that 10 milliseconds, we wait for the counter, see how many pulses we get back in that 10 milliseconds. We come down here and we set, when it's low, counter is equal to 1, or flags equal to 1, we can then say that the red counter is equal to this counter value, and then we want to set the pins S2 and S3 high, and that's going to read the green. So we follow through our if statement, we get down to the bottom, And this actually is not part of the if statement. So let's back it up so it doesn't look like it is. We set our counter back to 0. And then we go through this whole process again. We go through the 10 millisecond wait again. So we just keep doing this over and over again. And you see here we set, after we get the green counter, we set low, S2 to low and S3 to high. That's telling it to, I want to read the blue. So then we come down here, we set our counter equal to 0, and we wait for 10 milliseconds and our timer to go off again. And then we fall back into this loop because the timer went off. And we come back and it says, I'm now flag 3 because I'm reading blue. Set my blue counter, set it back to low, low, which is red. And then we fall through. And then the next time the timer goes off, the flag is set back to 0 and we start it all over again. So this is a little confusing because we've never really dealt with interrupts before on this show, but the whole purpose of an interrupt is to have the processor stop what it's doing and immediately go do this process. So in this case, we really have two types of interrupts. We have the one that is defined right here, attached interrupt, and it calls this ISR into, and what it does is every time the pin, you get a cycle on the pin, it comes down into this routine and adds one to the counter. So that's one type of, that's a physical interrupt. So this is one type of interrupt. Then we have the other interrupt, which is a timer. So what we do in the timer interrupt is we define this timer and we set it to its length to be 10 milliseconds. And we basically turn it on by putting a 0, 1 here. So every 10 milliseconds, it's going to fire off. So right here, what we've done is we said that this is what I want you to do when this interrupt happens. And then here's where we do our adding up of numbers. So after we set our pins to low, low, or low, high, or high, low, whichever one we're going to do, we wait 10 milliseconds and we wait to see how many count we get in 10 milliseconds. And that's the value of the color that's coming in. Now, one of the things that you're going to notice, and let me do a change here, see if this helps any, is we're right now getting a bunch of zeros, which I'm not sure why that is. Let me make sure I have all my connections tight everywhere. And we're still getting, and you see it just pauses. So this is a similar problem I was having yesterday with the Arduino itself. It seems like it just kind of locks up for a while, and I'm not sure what it's doing. But it appears that everything is functioning correctly on the sensor itself. I'm just not getting colors. Let me go look at different color ones, see what I get. All right, so there we're getting numbers. You see 116 red, green, 193. So it took me actually powering off the sensor itself and turning it back on. So let me change colors. I'm tempted to put a display on this just to see what it's actually doing, because it may actually be functioning normally, just that the serial output routine is not functioning the way that it's supposed to. And you see I'm getting all zeros back again, so I'm not sure. Oh, they're getting numbers. So it appears it doesn't like being on a surface tightly. So let me flip the coaster back over to the bright side. You can see I'm getting numbers there now. Nope, nothing. All right, so you see the frustration that I'm having with this. I will continue to play with the sensor, and if I do figure it out and get to work a little bit better, I was hoping this worked because I actually was going to, was thinking about building a robot that would follow colored lines, which would allow us to create a robot that would follow, so you have multiple lines, multiple robots, one would follow one color line, one would follow the other color line, and they'd be able to cross over paths. But I'm not having much luck with the sensor so far, as you can tell. I had more luck last night, but it still was not making sense. It was like, even though it wasn't moving, the numbers would constantly be changing. So it could be something, it could be a bad sensor, but I'm not sure. Hooking it up is not difficult. It's a little difficult to go through the program to figure out what it's doing, but I'll better comment what I wrote, and I'll put that out there in the show notes, and you can try to follow it and see. It's not horrible to understand. After you understand how it works. And just, all you got to remember is in a 10 millisecond period of time, it's going to pulse out how many, a number. So if say the value for red is 230, in 10 milliseconds it's going to pulse 230 times. So that's what the program is doing. And the values are between 0 and 255. So by theory, I should be able to take a number from the 3 numbers that I'm getting from it, put it into something like Photoshop, and get the color that it's looking at. However, based on what I've got back, that is not the case. That's not what I'm getting. So more to come on the sensor. So, but I don't want to go into to show you the sensor and tell you about what it does. Like I said, you see these kind of things when you're in like Home Depot or Lowe's, because they want to match your paint color. And it's the same type of sensor, just that this one doesn't seem to be working as well as those hopefully are working. Before we go into the last 2 sensors, and the last 2 sensors I put into one project, so this goes a little quickly, and this is actually a very fun one. I had a lot of fun playing with this one, and this was one of the last minute ones as well, but this one worked the way that it's supposed to work, not like the color temperature one. So before we go to that, I wanted to remind you that you can get the show, you can subscribe to us on iTunes or any other of the podcatcher services. We're on Stitcher now as well. Anywhere you can subscribe, but by subscribing, you get the downloads automatically, and you can play them on all kinds of devices. You're carrying your iPhone or Android around, and you want to listen to it as you're driving down the road, or you want to put it in your iPad or something and watch it. You can get us all over the place, and it downloads all automatically. You don't even got to think about it. So you get all the updates and all the episodes from Let's Make It all completely automatically, hands off. But if you're watching us on YouTube, there's a subscribe button there too. And that's another great thing to do, is subscribe to our YouTube channel, and you get updates that way. But if you want it on the go, the best thing to do is to go and subscribe to iTunes. Now, we are also now available on TiVo. So if you have a TiVo at home and you want to watch us on your big screen, go to TiVo, and we're listed in TiVo as one of the shows. And we are also have a app that is for Roku, and soon an iPad, iPhone, and Android app as well. So you can get us multiple places. And if you like what you're getting here, or you have a suggestion, please let us know. But also tell your friends. That's the best way for us to get the word around, is you. So if you do like it and you have some friends that you think you would enjoy it, let them know about us. That's definitely appreciated. All right, so on to our last project. Like I said, this is all done on one Arduino. I have 2 sensors on one Arduino. So let me go ahead and switch over on the Arduino. So I'm going to unplug this one and put it out of the way. And I will need this coaster for this next one. And let me get this one out of the way. And we're going to bring in the Leonardo. So we need to swap out our cables here too. Let me plug this in. All right, the Leonardo lit up. That's a good sign. Let me make a few changes on the Arduino software. Switch our board over to Leonardo and our serial port. Get that reassigned. And this is another one where I'm going to use the serial monitor. And the more I do this, the more likely I am in the future to actually do an LCD display, because going back and forth to the computer is difficult. So I want to talk about the sensors that I have here. This one, you can probably guess what it is by looking at it. It has like a little fly eye thing on top, but this is a motion sensor. So what this does is it detects motion, and it's very simple. There are some adjustments on it right here. You can make it more or less sensitive. I have not adjusted these at all for this. It just worked as I got it. And on the other side, there is 3 pins. You have your ground, your 5 volts, and the pin that comes high when it senses motion. Couldn't get much simpler than that. So we'll talk about this one. The other one is probably one you've seen around. I've seen a lot of these on websites everywhere. And it's a distance sensor. So it's limited to, I believe, 3 meters, and it's probably close to 3 yards. and no, it's 6 feet maximum. So it doesn't go real far. You couldn't use it for like sizing up a room, but it works great if you got some kind of robotic. It looks like little eyes. See, it looks like little eyes. But it works great if you got some like little robot that wants to determine where the wall is and things like that. So, and to demonstrate this, I actually have a ruler that I'm going to use and something to stick in its way, and we're going to demonstrate how accurate it really is. So it's pretty impressive how accurate it is. I was rather impressed. So the next thing here I want to do is switch over to the computer, and here's the program, and I call this presence and distance. So we have 3 variables at the very top. We have our pin that detects movement. Basically, like I said, the pin comes high when it detects any kind of movement, and we're going to monitor that pin. Then we have our trigger and echo pin, and the trigger and echo pin are used by the distance sensor to determine how far away something is. And it really is pretty much what it says it is. It's the trigger. It basically turns on the output, and then you turn it off, and then you wait for the echo to come high, and you time how long it takes for that to happen. And based on that time, you know how far away something is. And it's pretty simple. There's a little math involved I had to go look up to figure out how to do, but it overall is pretty simple. So let's go through the program. We set up our statics right here, and in setup we're going to turn on our serial port to 115200, and you see it over here, it's going. In fact, it's telling you that right now it's something 5 inches in front of the device. We set our trigger pin to output, because that's what we're going to say when we want to send out noise to figure out how far away it is. I also have set up the movement pin, which is the other sensor, as an input pin, and then the echo pin, which is the return from the trigger, as an input as well. And in the loop, we need to know the duration of the number of microseconds it took for it to come back, and the distance is something we're going to calculate. So we need to have these two defined, and they are long integers. And then we are going to write to trigger pin low, wait 2 microseconds, set the trigger pin high, which means it's going to transmit for 10 microseconds, and then we're going to set the trigger pin low. And then we're going to read in the echo pin in pulses. So this is pulse width modulation, which is something we'll talk about in the future of how you can control servos, and we'll talk about a little more about what pulse width modulation is. It's used a lot more than what people realize, but basically what it's going to do is it's just going to return a number. And that number is then, for inches, is divided by 148 to get the distance. And then we print out the distance in inches. If you're doing centimeters, I believe it was 58 is what I calculated it to be, 57, 58, something like that. And it'll return centimeters. And then after we print out the distance, we're going to read our pin, and if our pin is high, we're going to print out movement detected, and we put a blank line. We wait 2 seconds, and we do it all over again. So I'm going to move, first of all, the motion sensor. Actually, you see, I'm moving my hand in front of it. It just said over here on the serial thing, movement detected. So there it is again. It's seeing me move around it. So it's very quiet. You don't hear it clicking like a relay or something like that, like some of the motion sensors do in your home. It just quietly turns on the pin. So it is a very quiet thing. So now the next thing I'm going to do is I'm going to rearrange this a little bit, which you're not. Let me switch back over to this, and you see my ruler. And I'm going to set it right here. And I'm going to put this coaster at 4 inches, just like so. And then I'm going to switch back over to the computer. And if you look on the serial monitor, what's it saying? Oh, 4 inches now, 3 inches. Sorry, I moved it. 4 inches. And we go back over, and you see I'm at 4 inches. Well, you can't see where my hand's at, but I'm really at 4 inches. So it's pretty accurate. Let's say I want to go out to 8 inches. There we go. I'm at like 8 1/8, so maybe my 0 is not starting where I thought it was. I'm right on the edge of it, yeah. So if I come up to 2 inches, there's 2 inches. So it's very accurate. And you can see what I was doing, but this is why I need to put a display on it, because there was 2 inches. Let's go back. All right, 2 inches, 2 inches. We'll go to 4 inches, which is right there, 4 inches. So you can see it's very accurate. It's like I said, it's up to just a few feet. It doesn't go really far, so it wouldn't be good for, like I said, measuring anything of any great distance. Right now, it's, if you switch it over, you see it's saying 53 inches. So it's, you know, seeing a ways, almost 5 feet. And I think it could be the wall. I don't think it's quite the wall. Okay, so this is a great, fun little toy to play with, especially if you're trying to play a trick on your roommate. You can tell when they walk in the room. You can do all kinds of things. You can play sounds when you detect movement, all that kind of stuff. The distance sensors are great for if you're building a little robot. There's plenty of kits out there that have little robot attachments on them. You can add some intelligence to it. So this one's going to run into the wall. Like I said, it doesn't work for great distances, but if you're trying to run up against the wall, you definitely would know. And you saw me put it on the measurement there. It's pretty accurate as well, as far as the actual distance from the front. And what I found with the distance is actually from not the front of the sensor, but from where the element is in the sensor. So as I was playing with it here, and to mention of editing, you didn't see me do this, but it's where I put the measurement later on was actually the better place for it and a little bit more accurate. And that's basically where the sound is probably coming from in the back. So that's probably where the accuracy comes in. But these are very easy to work with. I mean, there wasn't no special libraries required to use either one of these two sensors. In fact, the one is just basically a high pin, which is very easy to look at, and the other one is a timing pulse width modulation, which is something that the Arduino is built to do. So it doesn't require any special libraries at all, like some of the other things we've been doing. And as I mentioned before, I will come back and revisit the Keller sensor, because I am intrigued by that one, and I have something I'd like to try to do with it. So I'm going to spend some time on that outside of the hour-long show, or hour-long this was tonight, to get that to work, because I would like to try to create some roving robots that follow different color lines and can cross over each other's lines, where if you just followed white or black, you wouldn't be able to cross over, you'd get confused. And I think it'd be pretty easy to do. We actually are going to talk about some robotic stuff here coming up. I'm already ordering some of the parts for it, and that stuff's on its way. The bulk of it's on its way. And so in the future, we will talk about some robots, and I think we can do some things with it and build upon a small, fun robot that would be like a little kit you could build just to learn how the Arduino works and write code for it. Actually, it'd be good for kids too, because the Arduino is very easy to use. And just getting used to the C language is the most difficult part, really. So that's kind of all I want to go over tonight. That's 5 sensors. Well, I guess technically it's 4 sensors, or 1 didn't work, or 4 working, 1 not working, properly working sensors for the evening. I do want to remind you, like I said before, if you want any of the stuff that we talked about on the show tonight, you can go to the bottom of the show page, or any of our show pages for Let's Make It, and we're going to have links to products on Amazon to get the exact products that we were talking about tonight. And that's already on there now, so if you're watching this, if you're watching it live, you can go down there and scroll down and get that. So I do want to talk about a little bit about our community. We have created a community on Google, that Google Communities, under Google G+, where we basically click on the community link. It's on our website, and you can talk to other viewers of TechZen TV and talk about the Arduino. I'm in there all the time. Not much activity here recent, but we're trying to change that. It's a new community for us, and we'd like to get that growing. So if you are watching us, go out and watch, or go out and participate in the Google Plus community. We also do have a fan page on Facebook as well. You can get to that from the main show page if you want to go out there. We do post updates about our shows. Each show has their own Twitter and Facebook accounts as well. And as we put content up, or new releases, or announcements of what we're going to be working on, then you can get that by just following us on either Twitter or on the community page. And lastly, before we let you go, I want to talk about show ideas. I have a bunch of show ideas coming up, but I'd love to hear your show ideas, because the best thing I can do is do shows that you want to see. And I have shows that I would like to do, but if you have something specific, I'd love to do them. So there are many ways you can contact us. If you go to the show page, you can actually contact us via Google Voice. You can call us and leave us a voicemail. Don't worry, nobody's ever going to be there to answer that, so don't get surprised by that. We can also, at the website, while you're there, you can contact us via email. You get all the other details about the show, as far as how you can contact us or make show suggestions. All the show notes are out there. They're out there generally the same day the show goes live, sometimes even before. That is our goal. We try to get very hard to get that stuff out there as it's released. We do record the show live on Tuesday nights now at 7 p.m. and we try to have it produced and up by Wednesday evening, Thursday morning. It's after we get it edited, it's kind of an automatic thing where it kind of does on its own. It just takes computer time to get it all uploaded and things like that. We'd love to hear from you. Give us some ideas what you want to talk about in the future. We'd love to hear that. And I do appreciate your time watching us tonight. And please come back next week. I'm not sure what my subject is next week. I have a long list of them, and it kind of depends on, I think, what parts I get in. But in the future, we're going to talk about integrating Arduinos and Androids together, different ways of doing that. We're going to focus a little bit on the Leonardo. One of the reasons I got the Leonardo is it can emulate a keyboard. So we want to talk about some items with that as well. And some of this may even spill in over to some of our other shows where we want to build tools for some of the other shows. And we'll probably use the Arduino for that too. I am still working on the project that I mentioned in the first couple episodes. It's been, I wouldn't say it's on hold, it's been going slow because of building out the new studio and everything. We're just a little bit behind on the time that I had to work on that kind of stuff. But I will come back to that as well. And that actually involves a Zigbee. And I may talk about Zigbee very soon just to show you how it works and how it works with the Arduino and some things you can do before I actually get into talking about the actual product that we're trying to create using the Zigbee protocol as well. So we have a lot of things planned, a whole bunch of project ideas of things you can play with, then learn the Arduino as well. And that's all coming up in the future. But again, I'd love to hear all your ideas. And in fact, if you want to send us a video, you can record it, stick it on YouTube or Vimeo or somewhere like that. Just send us a link to it. Don't try to send us a video. Our email doesn't take big attachments, so we probably wouldn't get it anyways. But we'd love to watch your video if you send them to us. So definitely appreciate anything you want to give us as far as show ideas, comments, feedback. We love it all. This show is done with our passion, but it's for you. So, all right, that's it for Let's Make It for this week. We'll see you next week.